Yeah, again, so my name is Masataka Maratari from JPIX. So I will serve as the session moderator of this lightning talk from now on. And we will have the 6 lightning talk speaker. So yeah, let's get started with this session. The first lightning talk speaker is Mr. Sean Fisher. Yeah. Please come to the stage. The title is Ending the IP Geolocation Headache.
Thank you. Hey, like magic. Hi everyone, I'm Sean Fisher. I'm the founder and ops manager at Vidr Online, which is a New Zealand-based telco. And I am turning in to have quite a passion for IP geolocation and the headaches that it causes all of us. So let's tear into it. So first off, why do I care? Look, I come and live in a small town here in Aotearoa of Te Tihiamaru, or Timaru, which is about 40,000 people. It's not huge. And we're known for various things, from our intrusive marketing of how to recycle, through to some less popular types of marketing. But we are a civilized small city, I assure you. But large telcos don't necessarily see that, and we sort of don't really exist on the internet. So looking in New Zealand specifically, all IPs sort of go back to Auckland, or a vast majority. And there's more to the internet in New Zealand and overseas, everywhere, than just some major cities. These can cause some pretty horrible headaches. I'm not sure if anyone's heard about the stories of a certain home that keeps getting sold every couple of months in Kansas, which happens to be dead center in the USA. Potentially, there's some issues there, where there are thousands and thousands and thousands of large IP blocks which just have geolocation based off WHOIS data of United States. So the poor people who reside in this house get FBI and various federal agents come to their doors for all kinds of nefarious internet activities they have no knowledge about. So it's more than just getting content served to the right place and from the right people. It actually has some real world impacts. So where is geo-IP data coming from now? Well, much to Jeff and Ali's disgust, it comes from WHOIS data the majority of the time. WHOIS was never made for determining the location of an end user of an IP. It's made for who has control over that IP, right? It's wrong, it's not right. But in fairness to geo-IP providers or geolocation providers, when there's no other information to go off, what do? Well, why should you care? So you can gain better IP address utilization because you're not having to delegate whole subnets to certain areas, especially those smaller towns. You can remove overhead from your team of submitting geolocation requests and corrections and data files and all that mess. Your support team gets a decreased amount of requests coming through from end users of issues accessing content or government departments, or not being served relevant content, like getting ads for girls near them, probably not in their location. And customers being able to access the right streaming services. Luckily, we have some RFCs that can help us. So RFC 8805 has existed for a while, and hopefully we all know about it. And essentially, it's a CSV file that contains your IPs or your prefixes, and then down into various ranges of information that gets submitted to the likes of Google, MaxMind on a regular basis. That works really well. You can also provide a URL manually to them. However, there's still a human element of work there of giving that data to a provider regularly. And sometimes I know some providers who are actually doing the whole process manually. So we now have, and here's the format of the CSV file. So essentially an IP address can be down to a /32, and for simplicity's sake, an example sort of feed here of ours is displayed on the right. Now, these can be individual IPs, they can be subnets, they can be v4, they can be v6. So it's the whole spectrum of addressing. And then you can go down into a country ISO code, region, city, zip code. Any information that you're providing is optional, right? So if you just want to have a country, fine, especially if you're, a small country. If you want to go down into an individual zip code, also fine. So just give the information you can. With RFC 9092, you can now have this feed in your Whois data. So rather than having to give this feed manually to GeoIP providers, cloud providers, streaming platforms, you can put it in a remarks field in your Whois with GeoFeed and an HTTPS URL, and they can go and get it themselves. This is actually becoming a really good method of GeoIP data. It's really widely supported. So you can see there all the top providers, MaxMind, IP Registry, IP Data, IP2 Location, all support this. And we've all had the scenarios of submitting corrections to MaxMind. It takes a week, couple of weeks. And you can see here the actual reactivity of these providers checking for your updates are even down to 1 day. So your updates happen faster, they can happen automated, and they're pretty widely supported by everybody. Why wouldn't you do it? So in APNIC, it's really simple to do. The biggest hurdle is actually getting the data out of your CRM platform, right? Is actually getting your CRM to export the CSV in an automated fashion and uploading it to somewhere that's semi-public, which you can restrict with user agents, etc. So getting that data out of your CRM, IP address, country, region or city, that's all you need. Hop into my APNIC, edit your iNetNums and your IPv6 ones, and add a remarks field with GeoFeed. Not sure if it needs capital G or not too game to try it. And with HTTPS is the other key. Needs to be HTTPS, needs to be CSV, needs to have GeoFeed at the start of the remarks field. There is an older GeoFeed field type across various RIRs. That doesn't work. That's a different thing entirely. So let's not confuse GeoFeed with GeoFeed. Different things. So remarks field, GeoFeed, CSV URL on HTTPS. Job done. Preferably with a valid HTTPS or SSL cert. That would be a good idea too. So what are the concerns of doing this? Why aren't people doing this? Because, it's a great idea as far as I'm concerned. There's a data visibility concern, right? Hey, I've got a CSV file of all my IP addresses and their locations public on the internet. Sure, I get that, but you could just have it to a country or to a region. You can also restrict that file to a specific user agent or array of user agents so that only the geolocation providers can access them, or to their source IP lists, which most of them publish a file that you can then load into htaccess or Nginx, whatever you want. There's no customer info. You don't have to be exporting, and please don't export any personal identifiable information. The other really cool thing about this is your data can be trusted, right? For a GeoFeed to be getting into the Whois of the IP block, it has to be the person responsible for the IP block. So there's no doubt over whether it's your IP or not. If there's an IP in your GeoFeed file that doesn't correspond to your IP block, it'll just be ignored. The chain of trust is gone. And again, it relies on us as telcos putting the info in correctly, but at least then it does reside with us. The responsibility is with us. We can control it. We can change it. The benefits, it's widely supported. There's no need to contact individual geolocation providers. Once you've got this remarks field with your GeoFeed, you don't have to go and tell anyone about it. They'll scan your ranges. They're doing this automatically. They'll find it. You don't need to tell anybody. You can get better IP utilization, much quicker geolocation updates. It fixes geolocation. There's also a really good tool called geolocatemuch.com. So once you have got your feed in your Whois data, you can go and chuck in one of your addresses. It'll spit out your Whois data, check your geofeed, find the IP down to whatever lowest subnet mask it can find. So we can see there I've entered 88.210. It's found 88.210/32, which is for a customer in New Zealand in Tekapo. Beautiful spot. Do it. Let's fix geolocation once and for all. We can do this. There is just one caveat, and that is getting the data out there is one dance, and it takes two to tango. The other side of it is getting the content providers, the streaming platforms, the people that are consuming these geolocation providers' data to update regularly. There are some out there that are only updating every 3 to 6 months. I'd love to see that come down to at least once a week so that we're supplying rapid information. The geo providers are containing that, ingesting that, producing those files, and then the content providers are actually consuming that on a regular basis. That's me. If you have any questions, I know you guys are eager to get out there and have a drink, so I'll be floating around because I'm just as eager. And you can get my details there or see me on LinkedIn. Thank you very much.
Thank you. So, I forgot to everyone. So, we don't have question time. So, for this lightning talk, and 10 minutes is allocated for lightning talk speaker. Yes. So, let's get to the next. The next speakers from Miao and Mr. Miao and Mr. Toyama-san. So the title is Peering Chronicles of Japan, the book translated. So please begin.
Hello. So I will quickly do this. Okay. So the Peering Chronicle of Japan. Do you know that? So 2 years before, we made this book in Japan. So this book contains the peering history in Japan, and not also the lot of the episodes told by many legends in Japan. And not only aim for the history book, but also this is the peering startup book for the younger generation. But then that was in Japanese. But this time, we translated it into English. And this one is free. So you can scan the QR code and please download. And today, Miao-san, he is in the Chinese, but living in Japan and working in the Japanese company, JPIX. He is one of the volunteer translator into English. So he will talking about some kind of his episode and content. Okay, so Miao-san, please.
Thank you, Toyama-san. Hello, everyone. My name is Miao from JPIX. I'm a volunteer translator who involved in this translation program in the book. So next, we're gonna talk about how we translated the book. And at the beginning, I'd like to share something how I connected with the book. Well, I actually read the book during a training program for new employees in JPIX, and I was recommended by our CEO. By reading this book, you can learn everything about the peering industry in Japan. Miao, you should read it. And then I got the book from hand and quite interesting reading. And during my first business trip in Peering Asia in Bangkok, I listened to a presentation held by Toyama-san because he asked if there is any volunteer who'd like to help to translate the book. I raised my hand and connected with him. Well, a few months later, I dared to submit some translation to him to wish to work on it quickly so that there will be more and more people who can learn more about the peering things in Japan, even though they do not speak Japanese. Well, I'm from China. Neither English nor Japanese is my native languages, but I can speak both of them. And it's quite a great honor for me to involve in the translation program, and we made it. You can even scan the QR code at the top right. It's free, and everybody can download it as a EPUB format. After 1.5 years, and we made it. So next page covers the test sharing between me and another translator whose name is Ono-san from Akamai, based in Tokyo. And I was in charge of many IX chapters like JPIX, JPNAP, and NSBIXP and BBIX. Well, so next, I gotta talk about NSBIXP, who is one of the chapters in the book, so that you guys will be interested in the book. And NSBIXP is an abbreviation of Network Service Provider Internet Exchange Point. It's actually very first academic IX in Japan, and owned by the White Project. It's launched in the year of 1994. The year I was even not born. The first version of NSBIXP was launched at the basement. You can check the picture over there. There is a basement at the underground of the building. And we operated NSBIXP first over there, and a few years later, we had our second version at the KDD Oldemachi building. And a few years later, and to avoid the single point of failure, we launched the third version in Osaka, the second largest city in Japan. But why IX was necessary in Japan? It came to the most important question. So we interviewed a professor who from Keio University named Akira Kato. Well, in 1993, there are two ISPs in Japan, which are IIJ and AT&T Gens. The interconnections between them actually had to go through the US, go through the Pacific Ocean. And the round trip time was very high. The communication was inefficient, while the price of the international circuits was also expensive. So we were like, how about exchanging the traffic within Japan? And thus we started NSBIXP in 1994. I also commented the same thing happened in Hong Kong as well. There are two ISPs in Hong Kong, which are Hong Kong Honor and HK Supernet. The interconnection between the two ISPs in Hong Kong also had to go through the Pacific Ocean. And Chiho from APNIC, who founded it, and he was like, how about make the traffic, the intra-Asia traffic exchange in Hong Kong locally. And Chiho did a lot of things, and they launched HKX in the Chinese University of Hong Kong as well. Well, at the beginning, there are some users like IIJ, InfoWeb, Fujitsu, and ITNG joined NSBIXP. But ISP was considered as a cannibalization with a transit business. So under a lot of pressure, we decided to limit it on the circuit bandwidth so that the traffic will not be too much. And we limited the circuits that ISP used to connect to us. It was still T1 circuit. I guess it's 1.5 megabit, not too much. Well, we also faced a lot of difficulties in operating NSBIXP at the time. The routing protocol was still BGP3, and there is no question mark in the router, but we have to check the heavy printed menus by your hands. We also seeing there is a greatly increasingly to upgrade the circuits because there are more and more users came to connect to us. But consider the negative impact on the ISP business, we didn't do that. What's worse, is launching in a basement. There is a power outage happened annually, which means we had to stop the service for half one day, and to do a lot of inspections. So consider that we had our second version, which is NSP XP2, started at KDD Ultimuch building, the very first data center in Tokyo. Why never forced participants to connect each other on NSP-XP, but luckily all the users connected with each other. And a few years later, we also faced a tax issue. And we also asked our users to pay for a participation fee, like NRC and MRC today's. After that, we were like, it's an academic IX. We expect something like commercial IX. And now we have JPIX launched in 1997, and then 2001 we have JPNAP, and 2 years later we have BBIX. A lot of commercial IX appeared in Japan in replace of the academic one. Well, lastly, I'd like to talk about some cultural difference between Japan and other countries and regions from overseas people who is working in Japan. So as you may know, each carrier has its own IXP in Japan, which is affiliated by NTT, KDDI, and SoftBank. Secondly, I'd like to mention that the sense of time is quite different. Maybe Japanese network engineers is quite sensitive about the latency time, the RTT time, or even the time to begin the meeting. I still remember there is a meeting that is scheduled from 10 a.m. in the morning, and I was told by my CEO, if you join the meeting at 10 sharp, you are late. In other words, being on time is late. You have to join the meeting 5 minutes prior to the meeting. I was like, oh, that's so Japanese. Oh my God. And thirdly, there are 4 buildings in Osaka, Dojima, but we had a connection issue between them. You had to, the communication should go through somewhere in NTT and then back to the buildings. Also, disaster management is considered well when you build a data center in Japan to prevent earthquakes, prevent flood, and yes, well, I don't have time, but lastly, I mentioned that Japanese people also pay the invoice very on time. It's quite different with some other countries and regions, but it's considered as a feature. Personally, correct me if I'm wrong. Thank you so much, and that's about the NSP-XP, and you can score the code again if you're ready. Thank you.
So enjoy this book. It's free. And also we encourage your own Peering Chronicle books, please. Yeah, thank you very much.
Thank you, nice talk. Please give a big hand again. And third speaker is Mr. Andy Panada Tamban. So please come to the stage. Off. The title is so busy.
Okay. Hi everyone. My name is Andi Parada Tambunan and I'm from Indonesia. So today I will present to you about one of my research. The title is Unveiling Attacker Strategy, Session-Based Analysis with HTTP Honeypot. Actually, this research I write in my papers. So the last step is reviewing. So why we use the honeypot for analysis attacker? We know several tools that we can use in the cyber defense, but in our research is focused on honeypot because the honeypot is a unique tools. So the purpose is honeypot is gather data from the attacker activity. So from the data, we can analyze the pattern and the tactics and techniques and procedure that attacker use for exploit our system. So the benefit using the honeypot is enhancing security insight, develop a better mitigation strategy, and the last, continuous learning and adaptation. Oh, sorry. So, talking about the attacker behavior, we focus about the tactics, techniques, and procedure. Because if we know about the tactics, techniques, and procedure, we can know what the vulnerability of our system. So, if we know, we can enhance our system to facing the attacker. So, if we know the tactics, technique, and procedure from the attacker use, we can analyze the behavior. So, in the next next time, we can forecasting that attacker will be tactics use. So what's the current problem? The current problem is previous study is only focused the raw activity. Actually, in Honeypot, we can gather many data, but the previous study is just focus row by row data analysis and mapping to the TTPs. So the impact is incorrect conclusion about the attacks and ineffective and misdirect security response. So this is our research. We run the 3 common honeypot, particularly in HTTP port. The name is Hellpot, Honeytrap, and Open Canary. So you can see many parameters that 3 honeypots use. Most of them is differences like timestamp, HTTP method, and so on and so on. So the limitation is cannot effectively identify multi-step attacks and lack sequential context between attack activities. Based on our experience by running 3 months, 3 honeypots, the limitation is we cannot know the multi-step that attacker use. So we have a new approach. We want to use some approach to analyze the attacker behavior using focus on the sequential of attacker activity. So if we use a new approach, the benefit is enable holistic and comprehensive analysis, reveal complex multi-step attacker behavior, and improve accuracy in mapping TTPs. So the implementation that we use is modify honeypot to lock session ID and use advanced analysis technique for session-based log correlation. Okay. So this is the sample that data that I got. You can look at the ID logs. This is the sequential log. But if we mapping per row, it's a different tactics, techniques, and procedure. But if we focus on all of the session log, it's just a one tactics that attacker use. So if we only focus row per row activity that attacker use is make our cyber defender misdirection information. So if we look all of the activity by the session, we can know the holistic tactics that attacker use. So the conclusion when we use the the honeypot, we propose a designs that importance parameter. You can look many like ID, timestamp, sensor type, source IP, source ports, and so on and so on. So the most important that we propose is the using the session ID. So in inherent in honeypot, we need to put our parameter is session ID to make some to make our honeypot to know the session, the activity session. Okay, that's all that I can present. Thank you.
Thank you. The next speaker is Mrs. Tenanoia Shimoa. Please.
Using this mic, okay. Hello again, Talofa. I presented this morning on disaster plan for telecom Tuvalu. Today I'll be focusing on how we rethink our business model in terms of adapting to the changing in the domain digital landscape. The presentation is basically to explore how we in Tuvalu are driving our strategy for the digital development that highlights 3 key projects development in Tuvalu. So I'm just going to give you a current stage and what we are doing right now, and then the ongoing plans. So as of now, we depend on satellite connectivity 100% at the moment. But we have a cable that is coming, and it will be delivered, landed by the end of the year, and hopefully ready for service by first quarter of next year. The current state of our network, we have a copper network, which is degrading every now and then due to the impact of climate change and sea level rising. And what is the next step going forward? As I speak now, my team in the islands in the progress of deploying FTTP network. In terms of mobile infrastructure, we have a 4G LTE mobile on the main island. We have rolled over, I think, from a year and a half ago, we managed to cover and extend the deployment of 4G LTE network mobile to the outer islands, half of the islands. And we are expecting to get that done by end of next year. For islands, for remote islands that doesn't have 4G LTE mobile networks, we provide them with community Wi-Fi, but coverage is very limited. So what we are doing right now, we are exploring our options on how we can deploy cell towers, shorter ones. So we are considering a 5G network for the future. In the morning, I kind of highlight the challenges that we faced from deploying infrastructure in these small remote islands, and the reason why we are exploring our options on other networks. Our country is 100% cash-based society, and we are leaning into creating a mobile money solution. And I'm happy to say that it's done. It's a matter of adoption at the national level, with the hope that we can do away, or we can do partial cash and then mobile money. Given that the cable is coming next year, what the company was doing was basically educating our young children, women, and our communities on cyber awareness and digital skills. So that's an ongoing initiative in the country. Okay, so the 3 main projects that we are focusing on, one is fiber to the premises, As I said, it will provide direct fiber optic connection to home and business because this is a project and we are a state-owned enterprise company owned by the government. We are mandated to provide fiber to every home and fiber to every businesses and government entities. We'll be providing high-speed internet once we get the cable in next year. And we are at this stage where from health sector, education sector, the deployment and the development of intensive application for helping our people in the remote islands. As you can see at the bottom, doing all this work, we are digitizing our work. As you see in the map below, we use IQGeo database, and it's a cloud-based solution that we're using to digitize all of our location where we get our pits, where the cable is terminated, can locate when the problem is occurred in which line and which home. So this will give us a quick response when there's an issue. In terms of 4G, we currently have 4G LTE network, and we are exploring our options on 5G networks. And as you can see, I've put in there towers. Very difficult, very difficult to construct the base towers, the base for putting the towers, because we are looking at 30-meter towers, 40-meter towers, because of the geo platform, like how Tuvalu is, is positioned. It's just a flat land. And for sure, this will help with bandwidth intensive applications. The last part, which is the main milestone that everyone in Tuvalu are looking forward to, we've been disadvantaged from being isolated, left out from the submarine domain. So the strategic partnership that we have with Google. So Google is laying a trunk cable from Guam all the way down to French Polynesia. Before landing in Fiji, they'll be constructing a branch for my country, Tuvalu. And it was a challenge because of the smallest in size of our country. And, it doesn't, in the past, people were saying, oh, there's no point of getting a cable to a country of 10,000 people. But hello, we are left disadvantaged from all the digital improvement, advancement in technology. And the reason why we went ahead and proposed present our case to companies like Google. So surely it will enhance our internet speed. I would say as of today, the total speed for my country is around 750, not 750 megabits per second, shared all over the country. And you can imagine that. And with the cable coming in, it will support economic development and pave the way for Tuvaluans towards digital transformation. It will improve our access to digital service and online resources. Strengthen our Tuvalu digital economy. We have a major project that I run under the Ministry of Communication, which we call Future Now project. The project was structured to combat the impact of climate change and how we can digitize our artifacts, our resources to be safe online. So what will be the impact of this cable to Tuvalu? It's going to improve everything, connectivity. It's going to improve services for health, enhance communication capabilities for not just for businesses and companies, but for residents living in the remote areas. And it's going to improve economic growth for the rest of the country. So we are excited about these developments as we see it as our pathway to digital transformation. And that's it. I'm not going to keep you long. Thank you so much.
Thank you for sharing the information. The next speaker is Mr. Taiji Kimura. The title is Let's Check Your RPKI and ROV Effectiveness. Please go ahead.
Hi, I'm Taiji from JPNIC, one of NIRs in AP region. The title is Let's Check Your RPKI ROV Effectiveness. This is calling for technical collaborators. ROV, as you may know, ROA is for certifying the origination of BGP route for some specific prefixes. And ROV is for checking the BGP routes with ROA. And ROA itself is getting popular, and over 70% of JPNX management IP address are covered by ROA. But ROV is not so easy. ROV, root origin validation, is still under consideration. I believe you also. Why? Because we are not clear on effectiveness. We know it should protect us from the misoriginated BGP route, but we didn't confirm yet, right? If you have confirmed, let me know. So let's check ROV with effectiveness with our collaboration. How? Firstly, making invalid BGP routes intentionally. Second, accessing from the invalid network to the destinations where you want to check it. Who is operators who can do this? Or maybe any other person can do the different direction, different tests. I will introduce when we talk. When? From October to March next year, but this is not limited to, we can extend, and maybe we will do further. Cooperations are needed. The purpose is to confirm and show ROV protects the specific services from invalid routes. This is not just looking at BGP routes. These specific services are like DNS servers, web servers, or any API server or cloud servers, or other important service you are doing. Then I believe those tests make ease decision-making on ROV deployment because we tested the effectiveness. And this means that the BGP path is dynamically changed, and ROV should protect for some periods, but the tests can show it was protected or not. The reason for collaboration, Internet is operated by this manner, collaborative manner, so we can see more details with collaborations. This is a picture of the I previously mentioned. Firstly, create invalid BGP routes and access to the target. The bottom of the circle square shows that AS with invalid routes, and any of the path, any of the peer ends should have a filter or ROV points. The target service should have the results for its reachability. If the accesses are failed, invalid BGP routes are filtered. So they means protected from misoriginated BGP routes. Very simple, and no attacks well, this is just the accessing from network to network. But the results can be short-term results because path is dynamically changed in the future. And the results can show unexpected AS paths. We don't only connected with the upstream, but also peers also. So collaboration needed. So please talk to me on this work or introducing collaborators are also welcome. Thank you.
Thank you, Taiji-san, for your information. The next speaker will be the last speaker of this session, Mr. Tom Harrison. The title is More Consistent RPKI Service for the Global Internet Community.
Hello, my name is Tom Harrison. I'm the product manager for RPKI at APNIC. And today I'm going to be talking about the NRO's RPKI program on behalf of Sophia Silva-Berenguer, who is the manager of that program. So the idea with this talk is to raise some awareness of this program and hopefully encourage some engagement with its goals and activities. So what is the NRO? The NRO is the Number Resource Organization, and it's an umbrella group for the 5 regional registries, and it helps to coordinate joint activities and communications for those registries. Onto the program. The RIRs come together fairly regularly to talk about their experiences with engineering, exchanging things that they've done, things that they're looking at doing, and so on. But when it comes to actually coordinating joint development and implementation work, things have proven difficult in the past. So the idea with the program is to dedicate some full-time administrative resources to this problem to hopefully get some forward movement in this space. And the purpose is, per this slide, to provide a more consistent and uniformly secure, resilient, and reliable RPKI service. So what is RPKI and why is it important, just in case? RPKI stands for Resource Public Key Infrastructure, and it's a PKI used by the RIRs to issue resource certificates to their account holders, who can then issue ROAs, Route Origin Authorizations. Those objects bind together prefixes and ASNs, origin ASNs, and then network operators can fetch all those ROAs from the RIRs to use them to validate announcements that they see in the network. There are other object types in development for RPKI, so it's not just about ROAs. In particular, there's the Autonomous System Provider Authorization, or ASPA, which allows an AS holder to attest to its set of provider ASNs, and that can help to do a sort of path validation in RPKI once it hits deployment. So why is the program important? The RIRs have all implemented and deployed RPKI in different ways. The table on this page is from a manners document from a few years back, and it just sets out some of the ways in which the RIRs do things differently. This is a particular problem for operators who work across the registries. It's just unnecessary friction and it makes things more difficult than it needs to be. So hopefully the program will help with this. Some examples of how things differ. Not every RIR offers delegated CAs or a testing environment or a sort of cloned production environment like Aaron's OT&E environment. Not every registry offers an API. Even more on the front end side of things, the ways in which the registries do things quite differently. Specifically for APNIC, we have this system that abstracts over the underlying WHOIS IRR, route objects, and ROAs in order to improve alignment between those two systems. But the other RIRs, no other RIR has exactly that approach. So it's just an example of how things differ. So here are a bunch of RIR user interfaces, and they're not all the same. And the question is, are these differences hindering the adoption of RPKI? So what are some outcomes we're looking for here? We want a definition of what a single global RPKI system looks like. We want better understanding and improved transparency of the robustness of the system. We want enhanced security consistency of the RPKI system across the different RIRs. And we want to make sure that the community is engaged along the way. As far as that single global RPKI system part goes, we are working on documenting the current set of features at each RIR. We are also working on a problem statement for the current trust anchor configuration. So the way RPKI works at the moment for trust anchors is that each RIR has an independent standalone trust anchor, and people have flagged at various points that a model with one trust anchor rooted at IANA or something like that would work better. So we've been looking into that. And also a survey and interviews to validate all of this stuff I've been talking about. There's a survey link on this page. If you have resources at multiple RIRs, please complete the survey. Okay, who is we, the program team? It comprises the NRO EC, so those are the chief executives of each RIR. There's the program manager, Sophia. There's the steering group, so the RPKI, people who work on RPKI at the RIRs. And there are some other RIR SMEs as well. Learn more and reach out. Visit our webpage, read our blog series, and we want to hear from you. So please fill out the survey. Please email rpki_program@nro.net. If you have any feedback or anything like that on RPKI, it'd be great to hear. Thank you.
Thank you, Mr. Harrison, for sharing the information. All of the lightning speakers, please stand up. And everyone, so please give your big hand again. Thank you so much. And if there is nothing to add, we would like to conclude the lightning talk session. Nothing? Yes, let's call it a day. So we will have the Meet EC cocktail from now on, inside the room, outside the room. Yes, conclude. Yeah, thank you.
There is only one of you, only one of me. There's a million of those who won't let us be, but they're not gonna